Hello again, class. So today I'm posting a phonology video. This is just like the morphology video I posted earlier, except obviously now this time I'm going to be going over how we might solve a phonology problem. So today I've chosen Canadian French, which is a medium difficulty problem. Again, just like the morphology problems, you should definitely watch this and try these out on your own because you will be doing phonology problems just like this one on the midterm. So again, just like in the morphology problems, it begins with the name of the language that we're looking at, and then a brief description. So I'll just quickly read through the brief description here, and I'll give you guys some hints on how to find some important information within them. So it says that Canadian French is a Romance language spoken in Canada. It is a dialect of French, and that our segments of interest are ta and cha. So this superscript s right here, this indicates affrication, so it's like cha. Are they complementary, contrastive, or free? And what conditions their appearance? And again, we're told that we have two vowels, u and I, are high front rounded vowels, which are tense and lax, respectively. Okay, so we're told immediately here that our segments of interest are ta and cha. So in a phonology problem, when we're given information like this, obviously we're given a pretty big clue as to what parts of the word we should be paying attention to. And then next we're asked the standard question that will basically appear on all of them, which is, are they complementary, contrastive, or free? And then what conditions their appearance? Well, it should be pretty helpful, I think, to go over these three terms again, even though they're covered in my lecture notes in the book, of course. So complementary, contrastivity, and free variation. So I'm going to begin with free variation just because it's the most uncommon and it's the one that we'll basically never do in class. So free sounds are two or more sounds that can appear in interchanging environments, or appear in the same environment, excuse me, but just interchanging. And speakers of the language should find that the word isn't incorrect or doesn't change the meaning at all. So an example would be the word, I'll just write this word, economics or economics. So for some speakers of English, the initial vowel here written in the IPA would be the high front unrounded tense vowel E, so like economics, and because I don't actually have a good symbol here for the sound, but it's the one that kind of looks like a capital E, economics. Both of these would be free sounds in English for this position of the word. So with economics, you can either say economics or economics. So I'll give you guys a quick definition then for free. This is two or more sounds that can appear in the same environment. And what will happen, right, is that they won't change the meaning or be considered incorrect to speakers. Run it without changing meaning or being incorrect. Okay, next I'll do complementary sounds, only because I think that complementary sounds are going to be the ones that we deal with the most in this class, because complementary sounds are the ones that will involve the rule writing, which is basically the hardest part of this and the point of doing these problems. So complementary sounds are two sounds or more that are underlyingly the exact same sound, but they can never ever appear in the same location. So one of the common ways of understanding complementary sounds in linguistics is to think of Clark Kent and Superman. So Clark Kent and Superman are both ultimately the same person, but both of them can never appear in the same place or at the same time, right? Because they're both the same. And sometimes when Clark Kent is fighting crime, he's Superman, and when he's in the office doing his newspaper reporting job, or I think that's what he did, then he's Clark Kent. So that is a complementary sound, and identifying complementary sounds can be a bit tricky. So complementary sounds will then, of course, be the main focus of these. So these are two or more sounds that are underlyingly the same. And never appear, or but never appear in the same place. Okay, and we'll be going over this notion of complementarity quite a bit more. Okay, contrastive is the last one, and it's probably the easiest. And this is when you're looking for minimal pairs. So contrastive sounds are two or more sounds that change the meaning of the word in the same position. So an example of these in English would be the words like cat and bat. Okay, the initial sound of cat is what we write as this, ka, and the initial sound of bat is what we write as this, ba. Okay, cat and bat. So ka and ba are contrastive sounds in English. This means that they will change the meaning of the word if they appear in different environments. And finding contrastive sounds, as a quick hint, is really easy. So I'll put now how to do this. So contrastive, how to find. You'll then find minimal pairs in the data set. Will be in the data set. Free variation is also really easy to find in the data set. So how to find. Your indication that you'll have free variation will be words translated in the same way. And then you can look into the transcription to see what is different about them. And those two sounds, the differences will be the sounds that are in free variation. So let's see if I can find a close one here. I can't find anything close that would really even look like anything that could be in free variation here. But imagine if we had another word. So we have here two, which means all. But imagine we had another word like boo that also meant all in Canadian French. Then we could say maybe ta and ba could be in free variation in this data set. But obviously, we don't see anything in free variation. And honestly, looking through for contrastive or free, they just often won't be found. So finding complementary sounds, well, how will you find them? You'll have to do this on your own, and you'll be the one to actually discover what the rule is to discover when in the language those two sounds or two or more sounds could appear that are in complementary distribution. All right, so now that I've gone over these, I'll just do this as to be continued. Okay, we can quickly look through this data set and let's see if we can find any words that are free. As I've already said, though, there will not be any words that are translated in the same way. So we can just quickly run down the gloss side and we won't see any words repeated. So there are no sounds that are free. Contrastive would be minimal pairs. So we can look through this and we can see if there are any minimal pairs in the data set. And as you will see, there are no two sounds that are minimal pairs. These ones are close. So tell and I can't put the nasalization too well on this, but like temb. These ones look like they might be close because they both begin with the same symbol. They both have the same vowel, and then they just have a different ending consonant. But again, the quality of the vowel is different. So in the word such, the vowel is not nasalized, but in the word stamp, the vowel is nasalized. So this one wouldn't actually count as a minimal pair. So lo and behold, as will often, dare I say, always be the case, you'll see that the sounds will be in complementary distribution, which means that, yeah, you wouldn't have found anything contrastive and you wouldn't have found anything free. So now we can answer the first question. So we know that these sounds are complementary distributions. So you could write down that these two sounds are in comp distribution. Okay, and that could be the answer to the first part. Now, this is where the tricky part will come in, and it says what conditions their appearance. So now you are going to be doing the part of the how to find for complementary sounds, right? We're going to now fill in this to be continued, okay? And we're going to write in a formal rule that will show us when the sound ta occurs and when the sound cha occurs. So you begin by looking at the data set, looking at the transcriptions, and I always begin by comparing the sounds that directly abut the sound of interest. So if you imagine that we were, I'll put this like in abstract form. So imagine that the segment of interest is X here. Then what I'll do is I'll always look immediately to the right and immediately to the left of that sound. Usually just one sound over will be far enough to look. Sometimes you might. So maybe I'll just say this is like a ba. and maybe this one could be a ta. Okay, you look at these sounds that immediately precede it and immediately follow the segment of interest, and it's within those segments that you will find the answer. Okay, so the easiest way of doing this and the most systematic way of doing this would be to literally go through the entire data set and just write out the beginning sound and the ending sound for our segments of interest. So you can do this by making a quick table. So I'll begin with the sound over here, ta, and then later in the table, we'll do the sound cha, which again, because I'm using my keyboard, I can't get a good superscript S, so I'll use the caret here to indicate that that's the T with the superscript S. Okay, so now we can just systematically go through the entire data set and put down all of the environments where ta is and where cha is. So in the first word, to, all, we see that the word is just tu. So the initial sound before the T is the word boundary, which we notate with the pound sign or the hashtag or whatever. We do an underscore often to indicate this is where the segment of interest is, the ta, and then it looks like the vowel that follows it was ew. Okay, and I'll go through and I'm just going to find all of the ta sounds, and I'll deal with the cha sounds later. So our next instances of ta occur in such and stamp, and this environment looks like the following. Again, we have a beginning of the word, so we'll use the word boundary, and then we have where the segment actually is, and then we have that vowel. Again, because I'm not using an IPA or I'm using just my keyboard, I'll use this capital E here to stand for that vowel. So there's that. Then we also have the same environment, except this one is nasalized. So I'll just do like again. And the nasalization won't actually be important, so I'm just going to get rid of it because it's a duplicitous entry. Okay, next would be telegram. So we have ta initial position again, so word boundary, where the ta occurs, and then the vowel that follows it, telegram, I believe. Next is very, so again we have it beginning the word, the sound ta itself, then an R. Then we have another T in the final position. So right before it we have that capital Y, that U vowel, the T, and then the ending of the word, which we can just put the word boundary down this way. Okay, and then the rest of our examples will all have the chas. So let's now start filling out the table for cha. So the first one we have is abuchi, which is ended, and what looks like we have before that is before the cha is a U, then the cha, and then an E. After that, we have timid, and so it looks like we have a word boundary, the cha sound, then another E, or the lowercase I, but the E sound is obviously what it sounds like in IPA. Now we have the word chit, or title. So again, we have a word boundary, the T here, and then the I vowel, which I'm just going to use a capital I for. And we have culture. Here, the initial sound or the sound before it is an L. Then we have where the cha is. Then we have another vowel, the E. And then the last ones begin like this. They begin with the word boundary, the sound of interest, and then a Y. And then the last one is a word boundary, so the beginning of the word, the segment of interest, cha, and then the E vowel. Okay, so now we have our tables made. So we should be able to compare the environments of these words much more easily now. So what you should notice is once you make a table like this, where you have all the environments listed, there should be some pretty glaring patterns that will emerge. So with our cha sounds, we can see that it looks like all of the sounds that follow the cha are all high front, rounded or unrounded vowels. So we have e, I, u, or u, and these are all high front, rounded or unrounded vowels, or tense or lax. Now, if you look over the T, it looks like we have a pretty strong pattern at the beginning, that T always occurs at the beginning of words, as notated by all these pound signs here. But as you can see, it's not going to be a good a good description of how that T occurs, because we can see that ch can also occur in initial position. So we would be creating an incorrect rule. So we can now notate what this rule looks like. And for this class, we don't need to get too complicated. So we can use pretty loose formations. So the way the rules work is they'll begin with the beginning sound, or the base sound. So we have a choice here between either ch, we have a choice here for the beginning sound is either the ta, or we could use the cha sound as the underlying sound, or the most basic form. One of the easiest ways of looking through to find out what the basic form is either to pick the simpler sound. So this one, ta versus cha, they're both essentially T's, but one of the T's has the special superscript S, so maybe we might say T is the more basic. Or another way is to literally just go through the data set and count them, and whichever one is the most common, or which one occurs the most, you can say that one's the underlying. So I can count up the T's here really quick. So it should be 1, 2, 3, 4, 5. And for the chas, we have 1, 2, 3, 4, 5, 6. As I'm familiar with this data set, it looks like actually the most common one is not the one that should probably be underlying. So let's just go with the more simple sound here, which is just ta. Okay, so the way the rules generally work is you pick the underlying sound, so I'll call that the UR, the underlying representation of the sound. Then you notate it with an arrow. So you say this underlying sound, this underlying representation becomes the following surface representation when, with this slash, and then you put down what the environment is that describes how these sounds are conditioned. So in ours, what I've said is that the underlying sound is ta, and I say ta becomes cha when it is the case, and it looks like at the beginning here, we have a variety of different sounds. We have an oo, word boundary, L, and more word boundaries. So maybe there's nothing there to really put systematically. And that's often what will be the case. Is that you'll find one side of the pattern has a really neat natural class, and then the other side will not. So in this one, we can say is that the sound ta will always become cha when it's the case. So when we use an underscore to indicate where this change will take place, and then we can just put curly braces to put in the set of sounds that condition the change. So for us, it's just e, and u. Okay, and this is the formal rule. So this says that T in Canadian French, T will become cha when it's the case that either the vowel e, or u follows it. So the rule of how to find this one could just be something like look for all the vowels like e, u, or u. Okay, and this is the final answer and basically the crux of the analysis, is to come up with a rule that looks just like this. And then you can, of course, check this rule against the data. So you should look to see if there are any instances of the vowel e, or u where there's a T in front of them. And so what we should never see just a bare T. We should always see a cha in front of all of these vowels. And if you go through this data set and you look at all those high vowels, you'll always find a cha in front of them, which is exactly what we want. Now, you might find other sounds in front of that I as well. So, for example, there isn't any reason why there couldn't be a word like, like A, B, E, so like abi. So I'll just write it in the IPA up here. There's no reason why you couldn't have a word like this in the data set. Obviously, this rule doesn't require that everything before an E is a cha. It just means that there can't be any T's before those vowels. Okay? And so that would be how you go through a phonology problem.